Welcome back to Geometry Chapter 10, Section 6 in this book. And what we're going to talk about is equations of circles. Now, we're going to review for a second first so you get your head in the right place. You know that if you see something like this with a y equals and an x, and they don't have any exponents, and you graphed it, it's a line. That's our y equals mx plus b, slope-intercept form. That's a straight line. You know that if it's got a x squared in it, it's a parabola shaped, the U, the parabola. We should put little arrowheads on everything, but oh well. Okay, so this is the equation for a basic circle. It's what you think of it for a circle. It's x squared plus y squared equals the radius squared. And this is true for all circles, that their center is the origin, where the x and y axis meet, right there on this one, at the point 0, 0. If that's where the circle is, that's what the equation looks like. And here I have one. X squared plus y squared equals 25. I could draw that circle. I know that there's nothing, I know that that's at the origin. I'll show you how to tell if it's not right here, but look down here now. And I know that the radius is, this is the radius squared. So all I have to do is take the square root of 25, and I get the radius is 5. I put the center right there at the origin. I go out 5 in every direction and make a dot and draw a circle. It's messy, but you can imagine it. All right, so that's just your basic equation for the circle. That will be on the SAT, the ACT, and college entrance exams. Make sure you know it. Very easy. That's a circle. X squared plus y squared equals radius squared. All right. Now, what about if it's not at the origin? If it's not in the very center, then it's been shifted. And I've taught y'all before about shifting a formula. And remember, H shifts it horizontally, H for horizontal, and K shifts it vertically, K for vertically. But that's not even spelling vertical, right, is it? But it gets in your head. Horizontal and vertical. You gotta say that K real hard. All right. So, and this moves it, it shifts it off of the center, okay? And let me go over, okay. So what you do is it shifts it the opposite sign from the center. So over here, see how this equation has a plus 2? It's going to go back 2. And see how it has a minus 3? It's going to go up 3. It does the opposite of what the signs are. And that's why they put negative signs there instead of positive, so you'll remember that. So it's x minus the horizontal shift squared plus y minus the vertical shift squared equals the radius squared. It's not at 0, 0, it's shifted horizontally and vertically off of the center, the opposite sign, and that's why those negatives are there. All right, so here's an equation for us to do. They say that this circle's center is at -4, 0, so that's our h and k, because the x is horizontal, y is vertical. And the radius is 7.1. What's the formula? Well, we substitute in h for the new x of the center. We put that into our formula here where h is. And we put the y, the new y center, in the formula where k is. Well, two negatives make a positive. So it's x equals x plus 4 squared plus y squared, because that 0 we don't have to write down, and we can just write y squared. And the radius is 7.1, so we square it and we get 50.41. And that's the equation for our circle that we described. So on the SAT, they will give you the equation and make you match it to the graph. Or they'll give you the graph and make you match it to the equation, both ways. Okay, so here's another one. This one has a point on the circle at 1, 2. And the new center, the HK, is 5, -1. And So first of all, we got to get the radius. So to get the radius, we can use our distance program in our calculator. If you don't have one, you need to get one. You can get it off of the Texas Instrument site, or from me. If you've had me as a teacher, I've already given it to you probably, unless you didn't delete it on accident. But if you've had me as a teacher, come back by. I've got cables, I'll give it to you again. So I want y'all to get where you do these programs so you can do this stuff faster. Because now they expect you to do math really fast. It's not just about accuracy, it's about speed also. Okay, so we put these in. This is x1, y1, x2, y2. We put it in our distance program. We hit enter, and they tell us the distance is 5. That's our radius. So now we can plug it into our formula. X minus h, so that's x minus 5 squared plus y minus -1. Well, two negatives make a positive, so this is y plus 1 squared, and then we square our radius and we get 25, and that's the equation. This one, it goes the other way. We have the equation and we are told to graph it. Well, first of all, we got to figure out where our center is. It's the opposite signs of these. This is the x, that's the y. So the opposite of 2 is -2, the opposite of -3 is 3. So we go, for x, we go -2 and then up 3, and that's our center. It got shifted back 2 and up 3. Our radius is the square root of 9. The square root of 9 is 3, and we draw our circle. That is a terrible looking circle, but I'm sure you can do better and look in the book too. Notice that with our radius, we only do the positive. You know, the square root of 9 is plus or minus 3, but we only do positive because distances are positive. Lengths are positive. You can't go -4 miles. That'd be like going back in time or something. All right, come back. We'll do 10.7, and it's about something called loci. That's fun to say, and that's the last section of chapter 10. So come back and learn about loci. Math is great.